what I was saying about the textbook, let's just go through that. Everything in the textbook here, you've got everything that will be in the tutorials, and down at the bottom, if I just scroll quickly down to the bottom, you've got example questions that you can answer with no penalty. There's nothing is recorded, nothing's there. So for instance, question 3 here, you've got nested brackets. You can do this question, you can expand the brackets, and then you can just check whether you're right or not. Then in the tutorials, in numbers, I've actually changed it so it says this tutorial has not been marked yet. Some of you will have noticed that you've got a series of crosses next to your answers. That's because they've not been marked. The assumption is they're wrong unless they've been proved to be right. I've changed that so it just says that this tutorial has not been marked yet. Under my progress, you'll see that you should see that you've got 1 mark. So I'd like you to check that and make sure that if you attended Tuesday or Wednesday, that actually the mark has been recorded. I've recorded most of the ones that were sent in to me, but I'd like you to check. So the stars are, this one is presentations, this one is tutorials, and this one is attendance. These two are lead, because I've not got any marks yet. This one is bronze because I've got a single mark, and as I get more marks, that will go from bronze to silver to gold. Okay, and obviously what you're aiming at is a gold. We've got a coursework mark here, which is the accumulated coursework mark, so that's going to start at 0 and hopefully is going to climb up towards 30. Okay, so that's the tutorials. I will come back to this in a minute when I have a look at algebra, but for now I'm going to get on with the material. Right, so let's have a whiteboard. So,
Tom,
yes.
if a student hasn't got a mark and they did attend a session, what would you like them to do?
Email me.
Okay.
Just send me an
Right,
email.
thank you very much.
Because then
Right,
I can find out what's gone wrong, yeah.
Okay, lovely, thank you.
Thank you. Okay, algebra. Today's algebra, and what we're going to be dealing with is terms. So terms are, what algebra does is it replaces numbers with a term, and a term is a number. So let me say 5a cubed. Okay, so that is a term, and it has 3 parts to it. The first part is the coefficient, the second part is the variable, and the third part is the, I need a different colour pen, third part there is the exponent. Okay, so that's the definition of a term. So it's got a coefficient, a variable, and an exponent. The coefficient is a number which can be 1, it could be 0, it could be 500, it could be infinity. So it's a number that goes in front. The variable is sort of anything you want it to be. I've used a, but it could be a1, a2, a3, x, x, y, z, anything you want it to be. And the exponent, I've given it a number there, but it could actually be a term itself. So you could have, instead of 3, you could have 5x squared, or 5x to the power of 6, or anything you want as an exponent. So there are basically no rules about what goes in here. It's just that each term has got a coefficient, a variable, and an exponent. Okay, now what we have to do with terms, let's just I can carry on writing. So what we do with terms is, if we've got an expression like 4xy plus 3xz minus 6zy, this is in the textbook, minus, and so on, what you've got to do is you've got to collect like terms. So in this case we've got a 4xy, this is a 3xz, so those two terms are not the same because y and z are not the same, and this is minus 6zy. There's really nothing I can do with this expression by way of simplification, because 4 and 6 share a factor of 2, 3 and 6 share a factor of 3, but obviously 2 and 3 don't, they're both prime numbers, so that there's no common factor between them. So what we need to, there's no way to simplify this, so that is as simple as it can be. So so when we're doing an expression, if we have something like 2x plus 5x, that's meant to be a plus, obviously they're both the same. The x's are both x's, so 2 plus 5 we know is 7, so that's going to equal 7x. But if we have an expression like 4ax squared minus 3ax, obviously we can take out an a, because both of them have got an a and both of them have got an x, so we can take an x out. So we can have an ax outside a bracket containing, so in this term here we've got a 4 left over. We've taken out an a and one of the x's, which means we've got an x left behind, and then on this term we've got minus 3, and then we've taken out an a and x, so that's the extent to which we can simplify that. Okay. Next thing I'd like to look at quickly is brackets. I'm going through this quickly because I suspect most of you have already done this, so it's by way of revision. So if we have something like 3x plus 2 times 4x minus 3, if I want to expand the brackets, some of you may know an algorithm called FOIL, where you multiply the first, the inner, the outer and the last. I'd like you to think of it in a slightly different way, which is to say, take the first term and multiply all of the terms in the second bracket by the first term. So what I'm going to do is I'm going to do 3x times 4x, so I'm going to get 3x squared. I'm lying to you, of course. Let me just undo that. Can I do it like that? Yes, I can. So it's not 3x, so it's 3x times 4x, so that's going to give me 12x squared. Okay, then I'm going to multiply 3 by minus 3, so that's going to give me minus 9x. And then I'm going to multiply 2 times 4x, which is going to give me plus 8x. And then I'm going to multiply 2 by minus 3, which is going to give me minus 6. Okay, so the way I've laid this out, and I'm not saying this is the only way to lay it out, but I've put it out so that I've got the highest order terms there, the next highest order terms there, and the next highest order terms there. I've got 2 terms in this bracket, 2 terms in this bracket, which means I'm expecting 4 terms, 1, 2, 3, 4, which means I can now simplify that to say that's going to be 12x squared minus x, because I've got minus 9 plus 8 and minus 6. Okay, so that's now expanded that bracket. Okay, next thing is factorization, which is, come on mouse, where are you? Factorization. If I've got something simple like 2x minus 4y, I can factorize that by taking a 2 outside, because that's a common factor, so I get 2 outside x minus 2y. Okay, obviously x and y are different, so they can't come out, and that's as simple as it can be. So you've got to make brackets as simple as they can be, but no simpler. That's Einstein talking, not me. Right, now the next thing I want to do is factorizing quadratic equations. So the standard form of a quadratic equation is going to be ax squared plus bx plus c. Okay, and how you factorize these is one of 2 ways as far as I'm concerned. You may know other systems, and if you do, that's absolutely fine, but the 2 ways of factorization that I'm interested in is, the first one is by inspection. And what I mean by that is, can you see the terms that are going to be able to make this? And the second way is by the equation. That was meant to be a Q, E, Q, U, A, T, I, O, N. Okay, so what do we mean by that? Well, let's take an example. Let's take x squared plus x minus 6. Okay, so what I would do is, you've got the minus 6 here. I'd factorize the 6, so 1 times 6 gives you 6, 2 times 3 gives you 6, and then 3 times 2 is a repeat of that. So let's see if we can do this. So we're going to put an x and an x in there, because x times x gives us x squared, so that's going to be that term. And then we've got a 3 and a 2, because obviously 1 and a 6 isn't going to give me that one there. So I'm going to put the 3 in there and the 2 there. Now, the product of the 3 and the 2 has got to give me minus 6, and the addition of 3x and 2x has got to give me x. So that is obviously going to be plus, and that is going to be minus. Okay, and then as a sanity check, I'm going to expand this, which is going to be x times x, which will give me x squared. I'm going to get x times minus 2, so that's going to be minus 2x. Then I'm going to get x times 3, so that's going to be plus 3x. And then I'm going to get 3 times minus 2, which gives me minus 6. Okay, and you can see that gives me x squared plus 3x minus 2x means I've got plus x, and then I've got minus 6. Okay, so that means that those two are the same, so my factorization is correct. Okay, this is what I call a sanity check. Okay, now what if we have a more complicated expression? What about x squared plus 8x plus 15? Okay, how are we going to factorize that? Well, I'm going to do this one by the equation. So where's my mouse? It's over there. Come on, mouse. So what I'm going to do is I'm going to say that the standard form of an equation is ax squared plus bx plus c. So in this case, I'm going to say that a is equal to 1, because the coefficients of these are the same. B is equal to 8, because the coefficients of these are the same. And c is equal to 15, which is the coefficient here. Now, the equation that we need is x is equal to minus b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Alright, so we're now going to put a, b and c into that equation. So x is equal to, b is 8, so minus b is minus 8, plus or minus the square root of b squared, so that's going to be 64, minus 4 times a, which is 1, so I'll put it in anyway, and c is 15. And that's all over 2 times 1. Okay, so let's do a bit of simplification here. So we're going to get minus 8 plus or minus the square root of all of this. Now I've got 4 times 1, which is obviously 4. 4 times 15, 2 times 15 is 30, 2 times 30 is 60. So I've got 64 minus 60, so that's going to be plus or minus the square root of 4, and that's going to be over 2. Okay, so we're almost there. So square root of 4 is 2, so that's going to be minus 8 minus 2 over 2, or minus 8 plus 2 over 2. Okay, so the two values of x, this is going to be minus 10 over 2, so that is equal to 5, sorry, minus 5, or that's going to be minus 6 over 2, so that is going to be minus 3. So what we're saying then is x equals minus 5 or x equals minus 3. So if x equals minus 5, what we can say is x plus 5 is equal to 0, and in this case x equals minus 3, so x plus 3 equals 0. So what I'd like to do now as a sanity check is multiply x plus 5 by x plus 3, and that's going to give us x squared, which is that term times that term, and we're going to get x times 3, so that's 3x plus 5x, and then we're going to get 5 times 3, which is 15. So that's going to give us x squared plus 8x plus 15. Alright, and let's make this smaller, still smaller. Sorry, it's getting very small, but what I wanted you to see is that this is where we started, this is where we finished up, and so my sanity check says that we're right. Okay, because that is the same as that. Okay, so that's factorizing a quadratic. Right, so now that's pretty much the content of what I want to do today. So what I'd like to do though, oh no, there's one other thing that I need to talk about, sorry. So let me get this back to a reasonable size. Oops, 100% will do. So there's one other thing that I want to do, which is called the nested form. So let's have the black pen, which is nested form. So let's imagine we've got an equation of the form ax to the power of 4 plus bx to the power of 3 plus cx squared plus dx plus e. Okay, so that's a general quartic polynomial. So if you're doing calculations in Excel or on any kind of computer or calculator, x to the 4 is quite an expensive operation. The power operation is really complicated internally. Obviously you don't get to see that, but it is a complicated expression is the word I'm looking for. So it's a complicated expression. So what is helpful to do in these sorts of circumstances, that's to the power of 4, so I'm going to put 3 brackets here, and I'm going to put ax. Then I'm going to put plus b, and then outside that I'm going to put an x. Okay, so if I were to expand this, I would get the ax squared and bx, but now I'm going to put plus c, and then outside that bracket I'm going to put another x, then I'm going to put plus d, and then outside that I'm going to put another bracket, another x, sorry, and then I'm going to put plus e. Now let's just count the brackets. Now how I do this is I start at the left hand side, and if it's an opening bracket I count up 1, and if it's a closing bracket I count down 1, and unless I get to 0 by the end of the equation something's wrong. So I'm going to go 1, 2, 3, and this is a closing one, so that's going to go 2, 1, 0. So I've counted up for the opening brackets and down for the closing brackets. I've got to 0, which means I've got the right number of brackets. And now let's think about how we'd expand this. So yep.
Tom, I think, so it's come up in the chat, I think you've put a B rather than D.
They're absolutely right. So whoever said that, spot on. So that is a B and that should be a D. Yeah, thank you. Right, so I'm now going to expand this bracket by bracket. So I'm going to start with this bracket. So I'm going to get ax squared plus bx. And I want 2 brackets left there. Then plus cx plus d, thank you for that correction, x plus e. Right, I'm now going to expand this bracket, so I'm going to get ax cubed plus bx squared plus cx plus d, and then there's a bracket there, and obviously when I do the next step, plus e, sorry, then when I expand the final bracket I'm going to get ax to the 4th plus bx cubed plus cx squared plus dx plus e. And if we compare that with that, we can see they're the same. So this is the nested form here, and this is just to prove that the nested form is the same as the non-nested form. Okay, so if you're putting complicated expressions into something like Excel or MATLAB or something of that sort, it's always better to use the nested form, which is this, rather than the sort of algebraic form that you would use in the equations. Okay, right, so let me close that then and just go on to the tutorials, because the tutorial is now open for algebra, and how this is going to be different from what you've done previously is that we now have to show our working. So instead of just a simple text box here, we've got this text area. So what we need to do is we've got to state the problem, i.e. what we're going to do. So what I'm going to say here is simplify, and then I'm going to copy that in. So that's the expression I want to do. So Control C, stick that in there, Control V. So that's what I'm going to do. I'm going to simplify that equation. So I'm going to press enter now, and at the top of the screen you will see my results have been saved. Okay, and my answers have been saved. And now I'm going to start, I'm just pasting that in. So I'm going to say that that is equal to, and now I'm just looking for similar terms. So I'm going to say 4xy, which is obviously that first term there. And I've got an xy here, it says yx, but they're the same as xy. So I'm going to say plus xy. Okay, then the next term is 3xz, so it's going to be plus 3xz. Then the next term, I've got minus 5zx there, so I'm going to say minus 5xz, because xz and zx are the same, they're commutative. And then finally, I've got minus 6yz, so minus 6yz. Okay, now when I press enter, it'll update my answers. So there we go, my answers have been updated. And now I'm just going to simplify this right hand side of the equation. Now I've grouped the terms together so that I've got two xy terms there, two xz terms there, and then the yz term is at the end there. So I don't have to write the left hand side out again. I can just say equals and then get on with the simplifying the right hand side. So I've got 4xy plus xy, so that means I've got 5xy there. I've got 3xz minus 5xz, so I'm going to get minus 2xz, and then I've got minus 6yz, so minus 6yz. Okay, which is my answer, but you've got to say answer colon, because that's what the system needs to know that that's your answer. So I'm just going to copy that, and then I'm going to say answer, and then put the answer in. Now you can leave the minus sign, the equal sign in if you want, or take it out if you want, absolutely no problem with that. But at the end of that, I press enter, and you'll see at the top of the screen my answers have been updated. So I've now given you the answer to the first question. That's amazingly generous of me, and that is how you put your answers into Baseline. So you have to show the working step by step as you're doing it, just as you would do it on paper if you were doing this as an exam question. Okay, that's me finished for the content of today. So what we're now going to do is we're going to go into the breakout rooms, and we'll be going through some examples just to make sure that you've got this. Okay.
Tom?
Yes?
Would you mind going through a logarithm example first?
I will go through a logarithm example first.
Thank you very much.
Yes, okay, thank you for nudging me on that. Right, I'll tell you what I'll do. If I go to the textbook equations and go and pick up a logarithm example there. Right, so that's the one I'll do. So that first one there, log x squared, or maybe 13 is the better one to do. So let's do 13. Right, so 13, yeah, there we go. Okay, so let me get the whiteboard back, and let me clear the whiteboard. Come on, clear it, and let's start that one. So what we've got is, let's have a pen. So we're going to go for log the square root of x minus log y minus log of 3x, and that is equal to log of x to the minus 2. Okay, so that's an example in the textbook. So what I'm going to do to start with is I'm going to get the y terms on the left and all of the x terms on the right. So I'm going to I won't mess with the signs straight away, I'll do that in a second. So what I'm going to do is I'm going to move this 4 log over to the other side. So I'm going to get minus log of y, and then these terms are going over there. So I'm going to say that's equal to log x squared, sorry, log x to the minus 2, not log x squared. Then this 4 log times the square root is going to become minus 4 log of the square root of x, because I've taken this onto the right hand side, and then I'm going to take the minus log 3x, so that's going to become plus log of 3x when it's moved over. Okay, so now what I'm going to do is I'm going to multiply both sides by -1, so I'm going to get log of y is equal to, and I'll write this term first, so it's going to be 4 log of the square root of x, because that becomes plus, then it's going to be minus log x to the -2 minus log of 3x. Okay, we'll do a bit of simplification now. So 4 log of that, let me just, yeah, I'll do it here. So that is the same as log of the square root of x to the power of 4. Okay, if you have a number here, you can raise it to the power. So this is like 4 lots of log of the square root of x. So I can just write it like that. And that's going to be minus log of x minus 2 minus log of 3x. Okay, so now I've got square root of x, which is like x to the half, and that's raised to the power of 4. So that's actually going to be log of x squared. Okay, minus log of x to the -2 minus log of 3x. Right, now remember, a subtraction with logarithms is the same as multiplication, and an addition is the same as, sorry, a subtraction is the same as division, and an addition like this one here is the same as multiplication. So that I can say that this is equal to the log, so I've got x squared there, and then I'm going to divide by, like write it out like this, x to the -2, and then I'm going to divide that, so let me put a bracket around that, I'm going to divide that by 3x. Okay, so let's simplify that. Come on mouse, where are you? There you are. So let's simplify that. So that is equal to log of x divided by x to the -2, so that's going to be x over x to the -2, and then that's also going to be divided by, so let's do it step by step, so that's divided by 3x, so we'll keep it like that for a second. So dividing x by x to the -2 is the same as multiplying x times x squared. So I've moved the x to the -2 from the denominator to the numerator, so instead of -2 it becomes +2, and then I'm going to divide by 3x. Okay, so that means...
Tom?
Yes?
The x at the beginning is x squared. Just...
Yes, so I've lost a squared from here. Okay, thank you whoever spotted that. That's an x squared and that's an x squared. Absolutely brilliant, thank you. So that means I've now got a log. I'm glad I've got people looking after me. So I've got x squared times x squared, which is x to the 4th. That's divided by x, so I'm going to get x cubed over 3. Okay, and that means that I've now got, so let me make this, no, I'll bring that down. So all of this is equal to log y. So if I write that in now, oops, down here, so this is log of y. Now, the key thing here is I've got log of a single bracket on the left-hand side and log of a single bracket on the right-hand side, which means I can now do the inverse operation, which is either anti-logs or taking the exponents, whatever you call it. So I can now write that y is equal to x cubed on 3. Okay, and that is the answer. Okay, so you don't need to put all these steps in. I've put all the steps in just to make it as clear where the things come from. Come on, where's my mouse? So you don't need all of these steps. So if you can see at a glance that, for instance, 4 log to the half is the same as log x squared, you could do that in a single line. And then these divisions, again, if you can see them, that's fine, go ahead and do them. If you can't see them, write every step in. It really doesn't matter. You've just got to write enough steps to make it clear for you to understand what's going on. Okay, is that all right? Is there another example you'd like me to do before we break out?
No, I think that's okay. Thank you, Tom.
Right.
We've just had a request for question 12.
Question 12, which is the log one. Yeah, 5 log and all the rest of it.
Yeah, sorry, I just managed to mute myself rather than answering your question, yeah.
Right. Okay, what I'm going to suggest is that we do question 12 in the breakouts. So, because I think it's not dissimilar to 13. The only reason I did 13 instead of 12 or 11 is because we got the 4 log the square root of x. So really the only tricky bit in question 12 is the 2 log x plus 4. All that means is you've got to square x plus 4 and you'll get an x squared term. So you're going to get a quadratic at the end. But let's do that in the breakout, shall we? I think that might be better if some people have a go at it themselves.
Yeah, that's fine.
Yeah,
yeah, no
and
problem.
if necessary, we can do it when we come back again. All right, so let's minimize that. Go back to this. Stop sharing the screen. Come on, mouse, which is there. Okay, we're back in the room, and we want breakout groups, and we'll have 3, shall we? 1, 2, 3. Ching. All right. So the list I've got is Sarah A is first, Sarah C is second, and I'm third. So shall we do 1, 2, and 3 in that order?
Yeah, no problem.
Yeah, that's fine. Oh, hang on. Junaid has got their hand up.
Yeah.
The questions are equations, not algebra. Where's this, guys? Can you give us a shout where about you're looking? Is it the tutorial or the textbook? On the tutorial, okay.
So
let's have a look.
You're saying tutorials, algebra. Yeah, it should be algebra that you see, not
yeah,
equations.
I can see algebra. Tutorials. The example is not from algebra.
Yeah, I think it was.
Mine's coming up as the algebra questions, so when I look
yes,
at
here.
mine.
And the log questions I was just checking. Yeah, the log questions are from algebra as well. Yeah, I think we're okay.
Yeah.
All right.
Yeah, I think so. So I just noticed something. Right, folks. The question Tom's just gone through is on the tutorial. It's not from the textbook.
Yes, I did it in the tutorial because you've got to show the multiple lines. So that's a benefit because the tutorial question, I've given you the answer to the first one. That's marked for free.
Yeah.
That's money for nothing and checks for free or something.
Okay, we've got a couple of issues where questions only go up to 8 on the tutorial. It might be, is it worth you refreshing your baseline just in case?
There's lots of A, B, C's.
Yeah, everybody seems to be stuck at 8 questions.
Yeah, there are 8 questions in the tutorial, but in the textbook there are 13 questions.
So you should only have 8 questions on your tutorial.
Yeah, that's right. There are just 8 in the tutorial,
right.
Each one of which has got 4 parts, so you've basically got 32 questions. But the log question I just went through was in the textbook. Because I don't want to do all the tutorial for you, because then, you've got all the answers, and that's no good. Right, okay, I'm going to go into the breakout rooms now. So
yeah, I think we're good to go now, judging by the chat.
Here we go, everybody. Gone.